y is equal to which of the following could be double prime. So what is double prime? What does f double prime tell us?
Concavity.
Okay, so what do we know about this graph?
It is concave down.
Is it concave
Wait,
down the entire time?
wait. No, it goes from concave up, concave down, to concave up again.
So what does that mean about our second derivative?
There's 2 points of inflection.
Okay, so the function has 2 points of inflection, but what does the fact that it's concave up, concave down, concave up tell us about our y double prime?
Goes through 0 twice.
Has to go through 0 twice. So it goes from negative to positive to negative. So you're looking for a graph that goes negative, positive, negative. None of them go negative, positive, negative.
That's positive, negative, positive.
Yeah, I'm backwards.
Concave
Up, down, yeah,
concave?
positive, negative. Oh, wow. I'm sorry, I'm really tired. And only one of those graphs does that, so C should be the correct answer.
Oh, can you explain it again? Sorry.
Yeah, so the function goes from concave up till about 1-ish. So it's going to be the graph of f double prime should be positive until there, and then it's concave down till about positive 1, so it's negative, and then it's concave up again after that. So it goes positive, negative, positive.
Oh, gotcha.
And the only graphs, like, they're not going to make it like super like, oh, you've got to know the exact details. There's going to be 2 graphs that do this idea. So they're going to make it relatively obvious. It's not going to be like super, oh my god, I can't pick between these two because they both do kind of the same thing. The graphs labeled above, picking which one's f prime, f, okay. So there's no 0 points, which kind of sucks. That usually helps us out. So I always try to pick and see which one's the derivative of the other one. And if you look at 1 and 2, they could be derivatives of each other. So really you got to figure out where 3 fits in. So just start looking, since you're doing derivatives, just look at the slopes. So if I do the derivative of like 1 or 2, they kind of go with each other. So they could kind of go either way almost. Because they both have a steep slope, and then they go towards 0, but never actually kind of reach 0. And so it looks actually more like 1 would be the derivative of 2. Because 2 doesn't actually go to 0. And then if I do, so it looks like I should go 3, 2, 1.
That's what I got.
Let's see what the answer is. And yeah, it is 3, 2, 1. So like I said, just start picking one, just start taking its derivative is honestly what I would do. Don't try to do the whole antiderivative thing. When picking graphs, it's a lot easier to do derivatives. So just pick whichever one you think is first, and then take its derivative, and it should match up to one of the other 2. If not, then it's not first, it's last. And then do the same thing with the next one and the next one, see if it has a derivative, kind of figure out the order. So
I couldn't figure out that 3 was like the original. I don't know why. Just the way it like looked. I was like trying to be like, okay, the slope is like slowing almost, I guess.
well, it's clearly not the any derivative of the other 2, because it starts at 0. None of the other graphs have a slope of 0 to start with, so it can't be a derivative of 1 or 2.
Okay.
So that kind of leaves you with the only option of it being the first one.
Gotcha.
And if you look, like honestly, especially with these, let the answer choices guide you. So like you should pick 1 first and take its derivative. Is that number 2? Pick 2 first. Is that derivative number 3, etc. Like kind of move through them the way that they have them in there. Don't just go like, you don't have to necessarily go randomly. Especially if you're not good at like kind of putting it all together real quick. Obviously, I've been doing it, so I have a little bit better experience. So I can just kind of look and say, oh, that's the derivative of that one. That's the derivative of that one. Okay, it's this order. But let those answer choices guide you. Like don't try to go from 1 to 3, because none of them go from 1 to 3. So see if 1's connected to 2, and if that's true, then A or C would be the correct answer. Stuff like that. Like let those answer choices help you. All right, number 3, the figure above is f, which the following could be f prime. That should be pretty easy, because you should have 1, 2, 3 zeros. just after 0, before 2, and in the middle of 2, so about 3. So you're looking for one that has that. So I feel like that's too far. So I don't think it's B. C has too many zeros, so yeah, D has the zeros in the right place. So that's all you got to really look at in this case. You don't have to look at anything else. Does that make sense?
Only 2 I answered, I've gotten right. So it's small victories.
That's good. But yeah, just look out key features, especially when going from F to F prime. That one should be relatively easy.
Yeah, that one was
You're
good.
just looking for that in this case, like I said, the 3 zeros, the horizontal tangent lines, would be what I would look for there. And that matches up to the only one of the graphs, so that's good. For acceleration, which is a projectile's max acceleration, did they really just do that? Okay, so you just want to know where the max of that function is. Okay. It's a non-calculated question. Okay, I was like, at least it's got to be something. So you guys know how to do that. Just take the derivative, set it equal to 0. Don't forget to plug in your endpoints. So whatever your critical values are, which apparently happen to be 2 and 3. So you check 0, 2, 3, and 4. And that ends up being D. Wow. What answer choice is not the correct one?
Hey.
Thank you. That's pretty funny, I'm not going to lie. Okay, 5.
Sure.
See, they gave you the cost equation, so...
Oh,
again,
I did not know how to do this one. I guess.
just take the derivative and find the...
Okay, I took the derivative. I get 14x.
Yeah.
Then I set it equal to 0. I get x equals 0.
You also need to check the endpoints.
Endpoints.
No,
What
no,
are the
the problem is
endpoints?
that C of x is the cost of all of them together, so you have to divide that by x.
Total cost in dollars, vaccine is according to model. Oh yeah,
Okay.
what is the size order is the cost per unit. So that's the cost. Yeah, they're tricking you there. I was like, okay, wait a minute, hold on. Helps if I read the full question. So you have to divide everything. So cost per unit, that's what they're tricking you there. So if you want to know, that's just the cost of everything. But cost per unit is, like Tanner said, you take the 7x squared plus 252 and divide it all by x. So they're sort of tricking you by not telling you what the actual what the actual function is.
So you take C of x and divide that by x?
Right, because you're trying to model the function for cost per unit, not the total cost.
Set that equal to 0?
Right.
Or do we take the derivative of that?
Take derivative, yes, sorry, and set it equals 0.
So, yeah, I would not know to divide that by x at all.
It's not necessarily like a blatantly obvious thing, not gonna lie. You have to look and see what they're trying to maximize or minimize. Just like with any of our other questions, this is an optimization question. So they're trying to minimize the cost per unit. So that means you need a cost per unit function to take the derivative of. So you just got to be careful and read into it. Obviously, it would be, if it was just a cost function, there'd be no minimum, or the minimum would be 0. So it'd be, $252, which is why they have that answer of D there. Because that's what a lot of people would do, is just take the derivative, set it equals 0, find 0, plug in 0, get 252. And they wouldn't realize it's cost per unit, not just cost. Because technically the only way to minimize cost is to not do anything. And that makes no sense. So they want to minimize the cost per unit that they're making. So that is...
You find the derivative of it, you set it equal to 0 and just find
your critical
the
point.
critical value.
Mm-hmm.
Get the minimum.
Yeah. And apparently the critical points as you're solving this are plus or minus 6. Obviously, -6 doesn't work. You can't make -6 units. So 6 is the answer, which makes a whole lot of no sense. That whatever they're making should be very large in that case, because making 6 does not do much.
Maybe it's like 6 yachts.
That's what I was thinking, like cars or yachts or something, maybe. It's like, I don't know, but yeah, that's weird. Okay, number 6. Blah, 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 naturally playing land. Okay, that's fine. We'll start at run dot, run up 4 miles. This best represents the determine the minimum time.
My Snapchat broken.
I don't know.
Can't send it.
So the first thing when I'm looking at these is I would figure out what t of x is, because if you figure out t of x, they're all different, so it doesn't matter what anything else is. So figure out what the total time function would be, and whichever one of those is correct is the answer. I'm pretty sure the rest of them pretty much says the same thing, as basically take a derivative, set it equal to 0, sign changes. Yeah, so literally the second part of all of these says the exact same thing for the most part. So really all you need to figure out is the time function. And that is...
how do you do that? I'm at a loss.
Time function is just distance times...
Distance divided by rate.
Distance divided by rate, yeah. I had to make sure I did that right. So it's distance divided by rate. So your distance for running is x. So it's x divided by 8. So that's why it's... so that automatically eliminates a. So a is out. So that's... Then we got to figure out what the time is for the swimming part, which forms a nice little lovely right triangle, as we can see. So your right triangle is, you would do, to figure out the distance, you would do Pythagorean theorem. So a squared plus b squared equals c squared. So your swimming distance would be equal to 1 squared plus 4 minus x in parentheses squared. So that's number B.
And why is it divided by 2?
Because you swim at 2 miles an hour. So it's distance divided by rate to get time. That's, I mean, really that's not even a calculus question, which is really sad. I don't know why they would put that in there. That involves like no calculus at all, because this calculus part's given to you. Okay. Whoever send that question's bad. 7 should be easy for you guys.
I missed it.
Did you do implicit differentiation? So on the
Yeah,
left, you should
I
have got
just
2y
forgot,
prime.
like... Yeah, I just forgot freaking what, like, how you find a horizontal. Oh my gosh, it's 0.
Yeah,
Never
dy
mind.
dx equals 0. So you take your
Yeah.
derivative, and then just make sure you don't run into any issues with y, and then figure out what your x value is. You had to be careful. X has to be greater than 0. Okay, so apparently there ends up being 2 answers. Yeah, so 1 and -1 ends up being the answers, but x is greater than 0, so x equals 1.
So okay, so you do implicit differentiation and then like you solve for y prime.
Mm-hmm.
But so how do you when I like solved it, I got like 3x squared minus 3 all over 2y.
Yeah. So you want,
and I
what do you know
0,
if
but
that,
how do I
right, so if you want the derivative to be equal to 0, how do you make that equal 0? Well, it's a fraction, so it's the only way to make it equal 0.
equals 0? Okay.
Yep. And they're only looking at the x values. They don't care about the y values. Obviously, y can't be 0, so you do have to check things like that. So you do have to be careful. Um, so in our derivative, y equals 0 is not a valid point because it would have like an undefined um, derivative there possibly. So you have to look and say, okay, well if x is 1, because you get obviously 1 and -1, but -1 doesn't work since x is greater than 0, then can I plug that in and get a point? Is that a valid point? So you just have to do that one little check, which usually they're not going to have you do. But it could have been if 1 gave you a value of 0 for y, then that would have meant that does not exist. Therefore, D is the answer. So you do have to be careful. Does that make sense? Hopefully. I'll take the silence as a yes. Okay, number 8. Blah, blah, okay. So you will have to take the derivative, which isn't too terrible. It's not pretty, but not the best. At points where x equals 3, the tangent. So when you take your derivative, so you should check to see if you get the right derivative. It should have been negative x squared minus 3 over y plus 2. So it looks like I is correct. So if I x is squared to 3, that means my numerator is 0. So that's fine. At points where y is equal to -2, the tangent lines to the curve are vertical. That looks to be correct according to my derivative.
So you said the derivative was negative x squared minus 3?
Negative, and then parentheses x squared minus 3.
Oh, okay.
Or negative x squared plus 3 if you want to distribute.
So, but when you said that equal to 0 to find the whatever, right? Wouldn't that give you wouldn't that be undefined because of the negative?
No. If x is square root of 3 or negative square root of 3, then the top becomes 0. And the bottom would not be 0. You do, again, have to check that whole bottom thing. It's a pain in the butt. But the bottom would not be 0. So the only way for the bottom to be 0 is if y is equal to -2. The only way for the top to be 0 is if it's negative square root of 3 or square root of 3. And those two things do not happen simultaneously. And then for 3, you just plug in 1, 1 to your derivative and see if you get 2/3, and you do. So all 3 of these are true. Okay, so the hardest part here, because answering 1, 2, and 3 saying they're true is easy. The hardest part in which where they can trick you, and especially with there being limited points, I'd envision not necessarily more tricks, but more like small things that they're picking up on this year. You do need to check to see if both the top and bottom are 0 at any of those points. Because even though the top is 0, if the bottom is 0, that means that you do not have a horizontal tangent line. That means you'd have an undefined or indeterminate derivative and stuff like that. So you do have to be careful and check that they're both not 0 at the same time, because that would have thrown number 1 and number 2 out of the running, and it would have been just number 3. But obviously number 3 only doesn't work, so do be careful and check those things. Okay, so how do you have number 9 horizontal tangent lines again? So top equals 0 and then vertical is bottom equals 0. So check your derivative. You should apparently get negative 2x minus y over 2y plus x. This one you have to solve a system of equations, basically.
Has a vertical tangent line when you said the bottom equal to 0.
Because you have a 0 underneath.
And horizontal.
Yeah, so you would get a number over 0, which is basically undefined, or really infinity is what kind of approaches. So that means your tangent line is getting more and more vertical as that goes on. As you get closer and closer to those points. And then top obviously 0. Now to figure out how many it has, you do have to be careful. You have to substitute back into the original equation. Um, so like if you set the top equal to 0, you get that y equals negative 2x. And then you have to plug that back into the original function to figure out where that happens. That is the tricky part here. And then solve for that. And you'll get 2 points. And then do the same thing on the bottom. And you get, again, 2 points. Does that make sense? Don't need to show anything out.
I just don't think I would have ever thought of that.
Yeah, same.
Yeah.
Back.
That's fine. I mean, this is one of those things. Like I said, this would have been like maybe a multiple choice question or so, so it wouldn't have been the end of the world. And I just still don't think it's going to be like a major portion of anything either. But it's those small things like that that are just some differentiators. That's all. I mean, you would have known to take your derivative. You just wouldn't have known after that to plug back in and stuff like that. So you get part of it. That's why we go over these things though, and kind of show you the different questions and ask things and kind of get you to make those connections. But remember, if you want to know how many points, and specifically when it says how many points on the curve, you know at that point you're going to kind of figure out how many answers for y do you have, how many answers for x do you have, things like that. So 10 should be easy for you guys.
Oh, wait. 10?
Mm-hmm.
I missed 10.
How do you determine concavity?
Second derivative?
Okay, what did you get for your second derivative? Hopefully it matches up to one of those.
I didn't. Well, I had x's in mine, so.
Okay, so what was your first derivative? Let's check that.
2x minus 2y dy dx equals 0.
Okay.
And then, like, arranged. Hold on. Let me find it.
So that's the correct first derivative. You should have solved for y prime, would have been a good idea.
What was your first derivative?
Dy dx equals negative 2x over negative 2y. Hold on, I'm trying to figure out how I just did that. Is that right?
Yeah.
Quick.
That's what I got, yeah.
Yeah, that's what I got yesterday. I just didn't pull it up.
Yeah, I said x over y would be the
Yeah,
the
so then
answer.
I took the derivative again,
Mm-hmm.
you know.
Which is
I
quotient rule.
sadly, yeah, I do quotient rule, so.
Mm-hmm. So what'd you get on the top?
I just don't want to look through my notes, so I'm just writing it out again. Well, obviously you have to put in dy dx again and everything. So I got 4y, I believe.
Will you write this one out?
I can, yeah.
Yeah, because mine got a little weird too after the second derivative.
Okay, so we all agreed the first derivative is x over y. We're okay with that?
Yeah.
Yeah.
Okay. Y prime is x over y, so y double prime, quotient rule, so low d high. So you get y, because y times derivative x, minus high d low, so x y prime over low squared, which is y minus x times x over y squared. So you get y minus x squared over y squared, which does not match any of their derivatives, so we got to manipulate this. So I'm going to multiply everything through by y, I believe,
Why you didn't how do you
to get rid of the fraction over here. So you would get y
it's
squared
X over Y back then. Okay.
minus x squared over y cubed. We're okay with that, yes? Everybody, I'm assuming, probably got that for their derivative.
Wait, I'm sorry. When you did your second derivative,
Mm-hmm.
it's like negative. Oh, junk. Never mind. Never mind. Never mind. All good.
Okay. So I'm assuming everybody probably got to there, right? Ish.
Yes.
Doing some fancy algebra. We get there. I'm running out of room. -1. Oh, I could. You substitute out the original function I gave you.
Oh.
Because I gave you x squared minus y squared equals 1.
What?
The original problem, the curve x squared
Yeah.
minus y squared equals 1. So,
That's crazy.
yeah. And before anybody says anything, no, I would not have just done that for funsies. It's because when I look at their derivatives, I realize that they have way different forms. So I have to say, okay, I've got to be able to change something. So clearly it's a y cubed on bottom if we've done everything correct. So how'd they get a 1 or a -1 on top? And you just kind of make that connection that we can substitute out things and set things equal to each other that they gave us. So not the easiest problem as far as that last step goes. But remember, this is why we always worked on the algebra skills, because they can make it any way they want to. So that's why we kept working on them. Any other questions on that one?
Funny thing is that does make sense. Like once you do it all the way out.
Mm-hmm. It just takes some practice. Like I said, it's honestly a lot of where you guys think I'm so good at math is just my experience. It's not necessarily that I'm amazing at math, but it's just that I have a lot of experience and I've seen a lot of things, so I kind of have ideas of what to do. Okay, number 11. 0.11 is on the curve. Okay, which of the following statements is true about the curve at 1, 1? I guess that's just analyzing the first derivative and the second derivative. That should be pretty easy.
Yeah, I did this one good.
So take the first derivative, plug it in, and figure out if it's positive or negative, and then take the second derivative, plug it in, see if it's positive or negative. Pretty straightforward question. The answer should be D. Anybody need me to show anything on that one? Okay, 12.
I'm good on that one too.
Okay, should be pretty much the same thing. So for obviously the first derivative is 0 because all of them say that, which is actually easy because you can plug in 0. And then just want you to take the second derivative, so that should be pretty easy for you guys as well.
So you just take the second derivative.
Yep, and plug in 0, 2, and see if you get a number it's negative. So that's B or D at that point. And then they're using also the second derivative test. What happens if your first derivative is 0? What does that tell you about that point?
It's a either like a
horizontal
relative extreme.
It's a critical point. Horizontal tangent line is also correct, but it's a critical point. So whenever the first derivative is equal to 0, and then the second derivative being negative tells you that that point is a, obviously since the answer is D, a maximum. Remember, second derivative test. So they're kind of combining implicit differentiation with that second derivative test there. So that automatically throws out C has to be wrong, and B has to be wrong, because those two contradict each other. So it's either A or D at that point, and once you figure out that the second derivative is less than 0, then D is correct. And you can kind of do it in either order, like figuring out that it's negative and then figuring out that it means it's a maximum, etc. So there's multiple ways you can do the problem. Any other questions on that one? Need me to show anything, do anything? All right, then moving on to free response. Part A. Okay, so
Unit 5, right?
what was that, Tanner?
We're on Unit 5, right?
Yes, sir. So A should be really easy for you guys. They even give you the second derivative of the function. Okay, cool. So, is it calculator active? Yeah. So definitely should have graphed that function and then just seen where it's positive or negative. So the answer should be for part A 0 to 0.464 and then 5.357 to 6. And your justification needs to be that f double prime is negative. What did you say, Bacon?
Was 0.4 what?
464.
436.
Maybe you just wrote the number down when you looked at the calculator wrong. Because the answer before rounding is 0.463 something. So I'm assuming you just wrote the number down wrong.
Second part right, so yeah, maybe.
Yeah. So that should have been easy. And your justification there is just that f double prime is negative. Does f have a relative minimum, a relative maximum, or neither at x equals 2? Justify. Okay, so that's pretty easy. They tell us that f prime of 2 is equal to 0. So what does that tell us x equals 2 is?
Or is a critical value.
It's a critical value, critical point, whatever. So how do we test to see if it's a max and min or neither?
Yeah. Using the first derivative test, we like to see what, like, if the values are positive or negative.
Can we use the first derivative test here?
Oh, so that's why I was confused on what to do.
So if we can't use the first derivative test because the information given us does not allow us to do that, we have to use.
Would it be the second derivative test, which is the opposite of whatever they tell us?
No, not the opposite. What you're meaning is it's the opposite of what you get when you plug in. But yes, it is the second derivative test. So you just plug 2 into that second derivative, get your value. If it's positive, that's a minimum. If it's negative, that's a maximum. So when you plug it in, you should have gotten
2 into the
3.
second.
Yep, plug it in the second derivative. You should get a value of 3. So by doing that, the second derivative test tells us that f has a minimum because the second derivative is positive and the first derivative is 0. You should get a minimum. Now, a couple of things to say on that. Remember, I would suggest not just plugging 2 into the second derivative, because when you're justifying, I'm saying you can just plug it in, but in your justification, you need to make note that the first derivative is 0. Remember to put down everything that is required for you to be able to say this. You have to put that down in writing. You can't just assume that they know you know this. So while, yes, they do tell you the first derivative is 0, you want to be like, oh, since the first derivative is 0 and the second derivative is positive, it's a minimum according to the second derivative test. And you don't necessarily have to say the second derivative test probably. You could just say since the f prime is 0 and f double prime is 0 at x equals 2, or is positive, sorry, then you have a minimum. But you need to reference the fact that the first derivative is 0 to get full points on justification. So please make sure you're mentioning all of the things that let you know that this is true, like the reasoning, like the qualifications, almost like it's a theorem. In this case, it's not a theorem that has specific justification or specific requirements, but the second derivative test does require that the first derivative is 0 to check for a max or a min. Okay, part C, use the mean value theorem. They usually don't tell you which theorem to use. That's kind of strange they did that there. But use MVT to show that cannot equal 8.5. Okay, that's pretty easy.
Well, see, I was confused because we don't have like the original function. Because it'd be like f of b minus f of a.
Uh-huh.
what do you do?
Hold on a second, let me read it there. Obviously, you need to use the mean value theorem on the points I give you, so that's definitely part of the point. So even if you can't do everything, show the mean value theorem out for 2 and 4. And you're doing the mean value theorem, so f prime. So this is where you have to be careful. You're using the mean value theorem actually on the derivative. So we're talking about doing that. So let's see what information I give you again. Yeah. Hold on, let's see. That doesn't make sense when I did this. This is a little more than I thought it was. Okay. That doesn't really use the MVT though. That's weird. Okay, so here's what they basically do. That's weird. So if f prime of 4 equals, what was it, 8.25? 8.5. Then what they end up, what they want you to make the connection is if I do this minus f prime of 2 over 4 minus 2. So you do the, find the average derivative, so average value, so do the secant slope in other words. Because remember when we're talking about the mean value theorem, the average rate of change has to equal the instantaneous rate of change somewhere. So what you end up getting there is that this is 8.5 over 2, which is 4.25. They then want you to make the connection that this being 4.25 means that f double prime of c has to equal 4.25. And in my opinion, you're not really using the mean value theorem there at any point, other than as a justification idea. So it's kind of a tricky question, especially when they tell you to use the mean value theorem. So you're really using the mean value theorem on the first derivative function, not the. It's a weird question, and it's not terrible, but it's not something I think very many students would get. This would be like a 1 or 2 point average question on a free response. Like people would not be getting this on average. But does that make sense so far what I've done?
Yeah, but like you said, I wouldn't have gotten that.
I wouldn't
Yeah,
expect
same.
very many, like across the nation, not just like in the class. Like I would not expect across the nation very many people to have made this connection, especially when they're telling you use mean value theorem. You're really using the mean value theorem on like f double prime. So the connection, like the thought you got to have when you're seeing these kinds of questions is the only function I have is f double prime. I don't have f or f prime functions, so I'm not going to be able to do much with those two. But I do know that these two I will have because they're telling me it can't be equal to that. So if f double prime of 4 is equal to 8.5, this is all true. But the problem ends up being that, was x squared e to the 2 minus x, right? Yeah. So the problem ends up being that x squared e to the 2 minus x, was it plus 1, can never equal 4.25. That never happens. So that's why this can't be a true statement. It's a very Um,
Hello.
Yeah, I was about to say, what's going on?
I don't. O'Donnell. I think you got cut off or something.
Yeah, I have no idea.
Should I was gonna say I'll comment on the Twitch, but I can only comment emojis.
On Twitch right now?
Discord. Oh,
oh, can you hear me now?
Yeah.
When did I cut out?
Yeah.
Let's have when did I cut out?
yep.
Somebody.
Like just before you started moving the camera.
Oh crap. That's. I wonder why my headset for some reason decided to go to sleep mode. So sorry about that. Again, yes, many of that is. I was like I asked a question, like a very easy question. And I was like, why aren't you guys answering? Then I see Tanner message what happened. So okay, sorry.
At first, I was on your Twitch, and I was like, "Oh, I'm gonna comment that I cannot hear him," but then I realized I can only comment emojis.
Yeah, I also don't read the Twitch chat at all. The Discord message will pop up as a notification on my computer, so I'll get that in a lot of cases if I don't have it pulled up.
Gotcha.
So, sorry about that. Yes, again, I don't expect many people to get this question correct really at all. It's a hard jump to make. I don't know if I personally would have gotten it correct, to be honest, without some extensive like thought. So like just looking down, trying to do it myself without looking at any kind of answer key or anything, there's a good possibility I would have missed something, or at least taken me a very long time to figure it out probably. But yeah, it is what it is. I mean, they're gonna put stuff like that in there. Part D should have been relatively easy though. So how do we know if we have a point of inflection?
If
Second derivative goes
like, if
from
the second
negative to
derivative,
positive.
and you find the like where it equals 0, and then if it's like positive or negative to positive, that's it.
Yep. So you take your, obviously you had a second derivative, so you don't have to test anything. And we've already done the justification of where it changes signs, and obviously does not change sign at 5. It's not even equal to 0 at 5.
So we
So
could literally just stuff we talked from part A.
yeah, you would just say, I would put some work there just to be safe, but they would never ask a question like that if you've already done A. Not on an actual free response, you guys know that. But yeah,
So,
you just
is it
reference it.
enough justification to just say that it's not a point of inflection because f double prime of 5 doesn't equal 0?
If you just said that, possibly not, because that's not a full correct answer. What are you missing?
I don't know.
So a couple of things. To be a point of inflection, it's not. We can't say that it equals 0. We have to say it doesn't change sign. So you need to.
Okay.
The better solution there would be to reference the fact that f double prime of x does not change sign at x equals 5. Or you could say because x double prime, or yeah, f double prime of at 5, or however you want to say it, because you had to mention at 5, does not equal 0 or undefined. Remember, you can have changes in concavity at an undefined point as well for those. But it's better just to say that doesn't change sign. So it fails the definition of a point of inflection, basically. So you always want to go back to that basic definition part. How long is part B? It's 2 questions. So yeah, we won't be able to finish today. Okay, so we'll do part B tomorrow.
Sounds good.